I'm going to take you through some of the basics of coding in Julia as I've learnt them recently. I've made some other videos below, which you can see below, about how to accomplish each of these various things in Julia. However, I'm putting it all together, what I've learned about Julia in this video to help out anyone else who's in the same situation looking at how to code in Julia. So the first thing I've got a list here of all the things I'm going to cover in this video. As you can see, I've actually put this in a Julia script to begin with, and I've used a comment at the start of each line to make sure that if we did ever execute this script, that it would never, my checklist, that would never actually do anything. So to comment in Julia, put a hash at the start of the line, and the rest of the line won't be executed by Julia. So for example, hash, this is a comment, nothing should happen. Excellent. So the first thing I've got here is variables. So to declare a variable in Julia, simply assign it to something. So for example, x equals 3, y equals toast, z equals the imaginary constant. There we go. Now interestingly, as part of this REPL, you can see all the workspace information come up on the left-hand side. I'm using Atom and Juno as the Julia IDE. If you're interested in what those are, I've got a video down below about how I installed Julia on my computer and how I got it all set up initially. Check it out, especially if you run into any trouble setting up Julia as I sure did, because it'll go through some of the ways I fixed it. So interestingly here, the complex number I put in is false plus true imaginary. So I wonder if we can do, so I'm just playing around a little here with the, interesting, false, okay. False plus true imaginary. Okay, anyway, so that's variables. You can assign a variable to anything. There's no special keyword to assign variables. It's just simply variable name equals value. We can also look at doing some maths on variables, which I'll get to later on. But first I want to declare some arrays. So my next step is arrays. Now what I've learned about arrays is there's simple one-dimensional arrays. One-dimensional. Form. Yep, a 4-element array. And there are also two-dimensional arrays. Julia provides a lot of convenient functions for initializing arrays. For example, ones will fill an array of specified dimension with ones. So in our case, let's do a 2 by 3. And we have ones in our array, or zeros. Let's do 2 by 3. Let's try a 3-dimensional array, which I haven't tried before. Oh, excellent. So it does manage a 3-dimensional array. What about higher dimensions? 1, 1, 1, 4, 1. Let's try a 5-dimensional array. And Julia seems to handle that perfectly. So that's an example. I think that's an example of a 5-dimensional array. I'm not sure how to read it. Is there a function that tells us dimensions? Dimensions of an array. No, okay, there isn't. Well, let's try dimension, just in case. No, there isn't. Okay, so as you can see, I'm still learning Julia myself. I've been a programmer I've been an engineer for about 10 years, and I've been programming for about 20 years. And over that time, I've worked in many languages, but I wanted to learn more about data analysis, and I'm using Julia to learn more about that data analysis. So I want to share my journey with the people on YouTube, so that you don't run into the same mistakes I do, or so that you can see some different ways to experiment with the language, just as I did there. So hit subscribe and follow along as I do this. You'll see I'll go through much more detail of how to code in Julia, but I've also gone into some more depth on some of these little forays, experimentations into the language in my other videos, so feel free to check those out. So moving on to types. Julia has it seems to be a very strict type system, I believe, where types are well defined and types must be kept. It's not like Python where you can just assume that things will behave as per some type. In Julia, the type is quite explicit. So for example, if I took, let's say, type of 1, that is an integer. This means 64-bit integer. If I did type of 1.0 is a floating point integer. This floating point integer. This means floating point number with 64-bit precision, or 64-bit floating point number, I should say. And we can do, I wonder if we can do this. So, okay, so what that's doing is converting 1 into a float, I believe, and then seeing if it's equivalent to this number. I think it's a type promotion, they call it. And I'm trying to think of a good example of how that doesn't work. So I've done a few previously. I've just noticed that there's a typo in my previous dimension. So if you have a function that only takes integers and you pass it a float, Julia may not convert in between. Your function would have to take numbers. Let's see if this works. So 1 equals true. So Julia does treat 1 as the equivalent of true. What about the floating point 1? Oh, that's treated as true as well. Okay, interesting. That's good. That's good. So that's the basics of types. There are a few other types, such as Boolean, complex. It's a complex set of integers. We've got fractions. We can do, so they call it rational. It's rational numbers. So we can do type of 2/3 is a rational. We can do type of hello world, which should be a string. We can even do type of. Now how do we tell it to use the function? No, okay, type of, let's try. Okay, there's some way to get it to tell you the type of a function or a type of an expression. It's called metaprogramming, but I haven't looked into that much more at the moment. I come from a JavaScript, Java, C++ background, so metaprogramming is only something I've looked at in terms of reflections. I haven't looked at it so much in terms of Lisp. Julia draws influence from. So anyway, there are various different types in Julia, and functions that expect a certain type must receive something in line with that type. You'll get type errors, and it helps I guess it helps when you put a program together to keep it explicit. So moving on to some arithmetic. All arithmetic is supported in the way you'd expect it to be. So 1 plus 1, 1 plus 2 times 3. You can see like that. We can do brackets. White space doesn't matter, as you can see. We can do 1 plus 2 times 3 divided by 4. There we go. And so all the arithmetic is there. We can do powers, 6 to the power of 5, 5 to the power of 5. It's, what you'd expect from a programming language. Some interesting things that you can apply arithmetic to complex numbers. So 1 plus 1 divided, let's do minus 2 minus 2, like that. And the expression works out. We can do multiplication the same way, plus 1 im. So maths works with complex numbers. It also works with fractions. The fractions I was talking about before. So 2/3 times 4/5, for example. And we can actually do, 2. Actually, I wonder what happens if we do divide. Divided by 7/8. So you can get Julia to do your maths homework for you if you're in primary school. Though I'm sure we can you have to rearrange the equation yourself if you want to solve for the missing number. So that's some basic arithmetic to do with Julia. It does look quite normal, I guess. Julia also, I believe, supports logical operations. I haven't tried these out myself. Been looking in the documentation about them, and I think it seems to support the all the standard sort of things you'd expect from programming language, such as bitwise operators. Yeah, that's what I'm looking for. I've got my notes here on the other screen. So let's see, we've got the number, let's try 15, and we want a bitwise not, which is -16. Okay. Can we represent binary numbers in Julia? No, okay, we can't. Let's try... Okay, let's take a look at some of the bitwise operations for Julia. Let's start with an unsigned integer of, let's try 7. Okay, and now we do the bitwise not of that. It's just that. And if you see, these are base 16 numbers, so that there's 7 different between 8 and F. It's so 8, 9, 10, 8, 9, A, B, C, D, E, and then F is the 7th. So that's why a not turns into this. We can also do, what's that, bitwise, we can do bit shift. So we can do uint 64 bit shifted by 2. So this is to shift everything along 2 bits, which raises it by the power of 2, I think. Which multiply. Oh, I don't know. It's been many years since I did bit shifts, but I can draw it on paper where it goes. Say it was 101, and you shifted it across by 2 bits. It'll be shifting across by 2 powers of 2, multiplying by 4 in this case. All right, yeah, there we go. So if I bit shift by 3, it should multiply by 8. Yeah, 7 times 8, 56. There we go. Okay. So some of the Julia supports logical operators, including exclusive OR, bitwise OR, bit shift. There's also a logical shift. I don't know what the difference between logical and arithmetic shift is. It's interesting. And it supports the in-place updating of numbers. So x equals 3. X plus equals 2, this will give us 5. It just adds on 2 to x. And the same can be used for the other mathematical operators. For example, this x equals 9, x mod equals 3 gives us 0. So it takes the modular and applies it to x. So 9 mod 3, apply that to x, and it becomes 0. Okay, so that's arithmetic. Let's look at strings. So a simple string in Julia is just within the talk marks. I don't believe it works with single. Yeah, it has to be double talk marks. We can do type of string to show you the type of the string. And we can concatenate strings. Now, one of the interesting things I found about Julia is that using the plus symbol on strings doesn't work. It will give an error and say that there's no method for plus of string and string, because Julia being so mathematics focused, the plus symbol is commutative, I believe is the right word, where it doesn't matter which order you do the plus in, both the result should be the same regardless of the order. However, when you concatenate strings, are we expecting this is the answer, or are we expecting this is the answer? And because that doesn't match with what plus means, Julia uses a different symbol to concatenate strings. It uses, just given away, star. So this will give us a string concatenation. And that's because the star symbol, I think it's called conjugation. I should know this because it comes up in electrical engineering. When you have 2 matrices and multiply them together, the order does matter that they're done in. So the same for Julia. So because the order of this string concatenation operation matters, Julia uses the star symbol. We can, some of the interesting, you can split strings, you can take the first. Actually, I wonder if you can take the first. There we go. Yeah. So you can treat a string like an array of characters. I wonder what happens if you do that. No, okay. doesn't let you go out of bounds on the string. Hello world. Okay, excellent. So function calls. You've probably seen me use quite a few function calls already. I've used type of, which is, as it says, a built-in function. So type of x, oops. This is the 64-bit integer. To make a function call, you just type in the function and press start. No, type in the function and call it with the enter key. So if then else, this is basic control flow in Julia. So if true, do something, print line true because it is, and so of course that evaluates. I did a whole video about command and control flow in Julia, so feel free to check that out below. I also looked at loops, so while true, this is going to kill my command structure. While true, print line and print line true, and it's just going to go forever. Can I interrupt it? Yes, there we go. We can interrupt. And I killed the whole problem. So while true, we'll just keep running in a loop forever. So that's some loops. Hopefully I've given you an idea of some of the basics of programming in Julia. This is a very basic lesson. I'll be going to some of the more complicated ways of programming in Julia. My aim is to build a dashboard. And so hopefully over the next few videos, I'll go into a bit more detail there. So hit subscribe, and I'll be bringing out those videos shortly. If you'd like me to go over anything in more detail, leave a comment below, and I'll create another video that addresses exactly that one. So I'll see you in the next video.